Hi everyone, this is Vivek. Welcome to my channel Alpha Q. Today we are going to discuss the most important questions of trigonometry. Let us get into today's session. Coming to first problem, in a right angle triangle ABC, 8 cm, 15 cm, 17 cm are lengths of AB, BC and CA. He is saying that it is a right angle triangle. So if it consider a right angle triangle, where we have to put the 90 degrees, as it is a right angle triangle, it should have 90 degrees. So in order to find out where the position of the right angle, first we have to find out the longest side. Why? Longest side is the hypotenuse. So in a right angle triangle, hypotenuse is the largest side. So the largest side here is 17 centimeters, and as it is 17, what is the corresponding side? CA. So take this as CA. So this is B. So the right angle is at B. Then we have to find sin A and cos A. So 8 is AB and BC is 15. So we need to find out sin A. So sin A, we know that opposite by hypotenuse. So sin A is opposite by hypotenuse, 15 by 17. Next, cos A is adjacent by hypotenuse. What is adjacent? 8. What is hypotenuse? 17. So next, tan A is opposite by adjacent, nothing but opposite 15, adjacent 8. So if you observe here, this can also be obtained by sin by A. So if you divide sin by cos A, we get 15 by 8. So 17 and 17 gets cancelled and we get 15 by 18. So this can also be written by sin A by cos A. Next, so we have found out, but the remaining can also be found. Remaining trigonometric ratios are cot A. Cot A is inverse of tan A, nothing but adjacent by opposite, nothing but adjacent means 8, opposite 15. So 8 by 15. This can also be written as cos A by sin A. Next, cosecant A is nothing but hypotenuse by opposite. Hypotenuse is 17. Hypotenuse is 17 and opposite of A is 15. So nothing but it is the inverse of sine. So 1 by sin A. Next, secant A is hypotenuse by adjacent. Hypotenuse is 17. So hypotenuse is 17 and adjacent is 8. So 17 by 8 is the inverse of 1 by cos A. So these are the 6 trigonometric ratios from this right angle triangle. Coming to next problem, the sides of a right angle triangle are PQ, QR, 7 and 25. Then find tan Q and tan R. So he has given in a right angle triangle, consider this as right angle triangle, given PQ is 7. Let us take this as 7 centimeters and QR as 25. Why I am taking 25 as longest side? Because we know that by Pythagoras theorem, hypotenuse square is equal to sum of the other two sides. So 25 square is equal to 7 square plus PR square is equal to 625 49 plus PR square. So 625 minus 49, if it transpose 49 to left hand side, then we get 576. So 576 is the square of 24. So the value of PR is 24. So this value is 24 centimeters. So this is the value of the side PR. Now what we have to find? Tan Q minus tan R. So the tan Q minus tan R is tan Q. We know that tan Q So trigonometric ratio tan is opposite by adjacent. What is opposite to q? What is opposite to q? 24 by adjacent is 7 minus tan r. What is opposite to r? 7. What is adjacent to r? 24. So 24. So this is the value of tan q and this is the value of tan r. Now take LCM. 24 576 minus 49 by 724s are 168. So 576 minus 49 is 527 by 168. So this is the value of tan q minus tan r. Now coming to next problem, cos A value is 12 by 13 and sin A and tan A should be found out. Consider a triangle, right angle triangle as 90 degrees here. Then cos A, let us take A here, B, C. So right angled at 90 degrees. Now take this as this is ratio, as this is a trigonometric ratio, it is adjacent by hypotenuse. So adjacent is 12k. Suppose this is 12k and this should be 13k. So in order to find sin and tan, we need to find out the BC value also. Now we know that by Pythagoras theorem, hypotenuse square is equal to square of the sum of the squares of other two sides. So 13k square is equal to 12k square plus BC whole square. Hypotenuse square is equal to sum of the squares of other two sides. Now 13k square can be written as 169k square and 144k square plus BC square. So transpose 144k square to LHS, we get 25k square is equal to BC square. So BC, from this we can find out BC by taking square root on both sides, we get by BC is equal to 5k. So the BC value is 5k. So this value is 5k. So from this we have to find out now sin A and tan A. So we know that sin A is opposite by hypotenuse. What is the opposite of A? 5k. What is hypotenuse? 13k. K and k gets cancelled and 5 by 13 is the trigonometric ratio of sin A. Now tan A similarly opposite by adjacent. So tan A opposite is 5k and adjacent is 12k. K gets cancelled and 5 by 12 is the trigonometric ratio of tan A. So these are the values of sin A and tan A. Now coming to next problem, here given that 3 tan A is equal to 4, this can be written as tan A is equal to 4 by 3. Now the same method we apply here. So tan A, here it is opposite, here it is adjacent. So opposite of A is 4 and adjacent is 3. Now we know that by Pythagoras theorem, hypotenuse square AC square is equal to BA square plus BC square. So 3 square plus 4 square is nothing but 9 plus 16, that is equal to 25. So AC square is equal to 5 square, as the 25 is the perfect square of 5. Now AC value is 5. We need to take 4k and 3k as it is ratio, so we get here 5k. Now if you observe here, as AC is 5k, sin A value is opposite by 4k. What is opposite? 4k, and hypotenuse is 5k. So we found out from Pythagoras theorem as 5k. So k gets cancelled and 4 by 5 is the trigonometric ratio sin A. Now similarly cos A is adjacent by hypotenuse. What is adjacent of A? 3k. And what is hypotenuse? 5k. So k and k gets cancelled and we get 3 by 5 as the trigonometric ratio of cos A. So the values of sin A and cos A are 4 by 5 and 3 by 5. Next problem. If angle A and X are acute angles and given condition is cos A is equal to cos X, then we have to show that angle A is equal to angle X. So let now consider triangle ABC and XYZ where angle A and X are acute angles. Now in triangle, this is triangle ABC and this is triangle XYZ. So now I am considering these two triangles where right angles are at B and Y and the hypotenuses are AC and XZ. Now if we consider from triangle ABC, we know that cos A is adjacent AB by hypotenuse AC. From triangle XYZ, cos X is adjacent XY by hypotenuse XZ. So from these two conditions already given that cos A is equal to cos X. Now given cos A is equal to cos X. So this can be written as cos A value is AB by AC and cos X value is XY by XZ. Now this can be rearranged as like this: AB by XY and AC by XZ. Now if you consider, these are the corresponding sides of the two triangles. So AB XY, so corresponding sides, and AC XZ corresponding sides. So these are the ratios of the corresponding sides and they have the common factor K. So let it be K. As they are equal, they have the common factor. Let us take it as K. Now from this, if you observe, the corresponding sides of AB and AC, XY and XZ are over. Now the remaining side is BC and ZY. Now we take the ratios of BC and YZ. So BC by YZ is equal to, we know that in a right angle triangle, hypotenuse square is equal to sum of the squares of other two sides, AB square and BC square. So from this Pythagoras theorem, we get BC as AC square minus AB square. AC square minus AB square under root. Since Pythagoras theorem, since we know that AC square is equal to AB square plus BC square, and YZ also similarly, YZ also XZ square minus XY square. So BC value is AC square minus AB square and YZ value is XZ square minus XY square. XZ square is equal to XY square plus XY square plus YZ square. So from this I am taking the values of BC and YZ. Now if we take these conditions as 1, from this equation 1 we can observe that AB by XY is equal to K. So AB is equal to KXY. So AB is equal to KXY and AC value is KXZ. AC value is KXZ whole square and AB value is KXY whole square by XZ square minus XY square as it is. So K square common XZ square XY square. So here k square xz square, k square xy square. As k square is common, I am taking the k square common and putting the xz square and xy square in a bracket. Now take the k square outside, we get k. So xz square minus xy square under root by xz square minus xy square. So xz square and x minus xy square gets cancelled and we get k. So which is nothing but bc by yz is equal to k, where k values are ab by xy and ac by xy. So we can write this as ab by xy, c by xz is equal to k value is bc by yz. So if we observe here carefully, ab xy corresponding ratio, ac xz corresponding ratio, and bc and yz corresponding ratios. So as the corresponding ratios of two triangles are equal, then those two triangles should be similar. Therefore triangle ABC is similar to XYZ. So as the two triangles ABC and XYZ are similar, then their corresponding angles also must be equal. So angle A is equal to angle X, since corresponding angles are equal in similar triangles. Corresponding angles are equal in similar triangles. So angle A is equal to angle X, hence proved. So that's all for today, friends. Thank you for watching my video. If you like my video, subscribe and share it with your friends. Thank you.